Okay, there we go. Well, first off, just good evening, everybody. I really appreciate everybody's flexibility with this. For everybody's awareness, we are recording this session, and a copy is going to be made available for those who are unable to attend live. For tonight's format of the meeting, it's a little bit different, but I'll start by introducing our guest who's going to discuss his connection to uncrewed and autonomous systems. Afterwards, I'll lead us through some introductory questions, and then we can open it up to class-wide Q&A. I do ask everybody mute your mic, save any questions to the end, and that you use a hand raise icon to indicate when you do have a question. That way I can call on you in order. With that, I am just thrilled to welcome you to our 35th session of the UNSY Guest Speaker Series. This is the second of three for the term. I'm Dr. Brent Terwilliger, the program coordinator for the Master of Science in Uncrewed and Autonomous Systems degree here at Embry-Riddle. Tonight, we are joined by our guest subject matter expert, Dr. Stephen Harbour. Dr. Harbour is a senior leader in defense research and engineering professional with over 25 years experience in multiple engineering and aviation disciplines and applications. He possesses subject matter expertise in neuromorphic engineering, artificial intelligence, machine learning, human autonomy teaming, neuroscience, electrical and computer engineering, avionics, human factors, UAS and autonomous vehicles. He also serves as the AI hardware research director, where he leads Brain as the principal investigator and is the author of over 50 papers in nanotech, nanoscale architectures, to include microcircuit design with AI algorithm spiking neural networks. And to top that off, he's also served as a Global Hawk Chief of Avionics Engineering and Modernization Programs. He supported the Air Force Research Labs Sensor Directorate at Wright-Patt Air Force Base, as well as the Air Force Life Cycle Management Center in the Intelligence, Surveillance, Reconnaissance, and Special Ops Forces Directorate. He's a former U.S. Air Force fighter test pilot with over 5,000 hours in an F-16, an F-4, an AT-38, a T-37, a B-52, and EC-135 aircraft. He also flew the MiG-29 as part of the U.S. State Department's military-to-military visit program, and he has a PhD in neuroscience with specializations in AI, machine learning, and neuromorphics. He also has an MS in aerospace engineering and mathematics with specializations in AI and ML, avionics, controls and displays, and then a BS in electrical engineering with specializations in robotics and feedback control systems. Dr. Harbour also teaches at the University of Dayton and Sinclair College. With that, let's give a warm welcome to Dr. Harbour.
Thanks, everybody. Yeah, wow. I feel very honored to hear that, Brent. I guess I don't oftentimes actually listen. You did a very good job of introducing me. I'm not worthy, really. Yeah, I love the research that I do and the folks that do it with me. And so AI and ML are vitally important, obviously, now and in the future. And I focus both on hardware at the microprocessor level, edge computing, things of that nature, but then also at the software level and algorithm development, spiking neural networks, convolutional neural networks, and we call these things like Gen 1, Gen 2, and Gen 3, AI ML. Gen 1 is rather statistical based, a regression analysis. To Gen 2 gets to be like a convolutional neural network. And then Gen 3 adds the spiking neural network, which is very much like our brain, our human brain operates. And we do it to imitate the brain because the human brain is an amazing computational tool. It's extremely efficient. We're talking probably 10 watts a day to operate, and the operations per second in computations that we can do in the brain are absolutely amazing. And so we talked some years ago with Neuroscience Neuromorphics to explore that area on taking the microprocessor and designing it to be full of neurons and behave like the human brain. You can do that either through software or hardware or combine it. And so the brain processor that I'm the PI for is analog based, which is like the brain is analog based. It's not digital. And it has baked in, if you will, characteristics of, it's in silicon, but, of the human brain neurons that we have. We have, 100 billion and the state-of-the-art cutting-edge processors that imitate are like at 1 million. So just scratches the surface we do. And so it's taking AI to the next level. And in experimentation, I've done drone work, UAS work, using a neuromorphic processor to control the drone and have it fly itself with an optical camera. You can use a high-res camera, or if you go for pure neuromorphic, you use like a neuromorphic event camera. All of this stuff is rather new in the research area. And so that's where I live, and that's where I do my research and push the envelope for a variety of customers, primarily the U.S. government, but it's it goes beyond there. I mean, AI also electronic warfare. So we're using cognitive electronic warfare also with spiking neural network kind of arrangement. So we're really doing some pretty cool things. So and so you guys are in a cool field on what you're doing, what you're studying, what Brent is instructing. Pretty amazing. And Embry-Riddle is a top school. There's no question about that. You guys are in a #1 program, and my hat's off to you. I'm more than happy to answer questions that you may have. And sorry about I don't have a slide deck. I'm in an unusual situation. I can certainly follow up with a slide deck. More than happy to do that. I can answer questions and go from there.
Outstanding. Well, I'll kind of kick us off on some exploratory questions. You mentioned, working with UAS technologies and AI machine learning. Hey, folks, can you make sure you're muted? You mentioned that you are working with AI technology, machine learning, computer vision. What is it that you see the advantages of AI compared to, say, manual teleoperation of UAS, or even just the basic autonomy that we've had over the few years? What are some of the new capabilities, the adaptable mechanisms that we're starting to see?
I gotcha. So I look at AI, and I think this is getting to be more common in the community, is not necessarily a replacement for the human necessarily, but as an aid or a teammate of the human. So if you have a lot of UAS systems in flight with various missions, it may take automation, AI involved, to keep the formation together, to execute the mission. But at the same time, we're integrating the human into the formation. So you may have like an F-16 with a human pilot, and inside the F-16 may have an AI agent to aid the human pilot. And then the other formation members may be the same way. And then you go straight to the UAS. You may have 5 to 10 UAS aircraft in the formation with 4 F-16s, and there's no humans in the UASs, but they're integrated with that entire formation, and a lot of AI is used to maintain safe flight of those and mission execution. And so we're seeing that kind of growth in AI. At one point, it was believed that AI was going to replace human drivers, human pilots, and things of that nature. And not so much. It's really made to reduce the workload of the human, but not necessarily replace the human, and the human can turn it off anytime they choose to. That's how we're starting to structure it now. Clearly, if the human or humans are impaired, things of that nature, then AI will engage and safely take the system over. So I think that's what we're seeing, the growth, and you need higher technology, better technology. And so that's why we're designing new processors to handle those kind of workloads and algorithms, say 3rd generation, and that use low power. So if you use neuromorphic processors, they use a fraction of the power than a GPU. So as opposed to, frying your breakfast on your gaming computer with the GPU system, or even in the system you have, 500 watts to execute, train the ML AI for that system, use something neuromorphically, and now you're like in the fractions of a watt, orders of magnitude less energy, but then yet you're getting a faster response and processing speed when you go neuromorphic. So I really think that we're going to be getting away from GPUs, which are power hungry, and they pretty much have taken over our server farms and use. In fact, ChatGPT actually has a bigger carbon footprint than, say, about 3,000 cars in a week's time. So we're going to address that, and I think the neuromorphic technology is a way to do that. Example, Halo Point by Intel Neuromorphics is doing that with several low-eking chips for a lot less power usage and quicker operation. These are things that you can look into. So you can, for low swap on a UAS, or low size, weight, and power and heat, you can go neuromorphic. You can go Gen 3 AI ML and do the same thing or better computationally for a lot less power, a lot less space. And I think those are the big breakthroughs in AI ML, and then realizing that it's really to aid the human as opposed to take the human position over. So that's what we're finding.
Outstanding. What are some of the common misconceptions people have about AI capabilities or even the development of AI?
Yeah, so the common person probably thinks that A, it is going to take over their job, and or B, is going to take over the world, like Terminator, 1, 2, and 3, and those type of movies that is going to take over, make its own decisions, be self-aware. We are nowhere near self-aware computation. Humans have that ability to be self-aware, quite frankly, but obviously, but computing systems just simply don't. I mean, we can make them more efficient. We can make them process better, make decisions quicker than that. As we advance, but to have that self-awareness and truly be independent, I don't think we're going to really get there per se. It's going to be ever improved, but that's probably going to maintain a human. It's going to be pretty rather human to do that. I have some theories involved with entropy and energy and chaos, and when a system or a human doesn't understand something, the entropy gets high, they want to lower it innately, so they learn, and applying that to a computer. I've looked into that, but that's all very theoretical. So I have no worry that a computer is going to take over in humankind and will be non-existent. I do think that we have to be cautious. I think it was believed that self-driving cars were going to pretty much be the norm, and that hasn't happened because the human is still a safer driver and accident rates than AI, and the environment that we have. It's not going to go away.
As long as we can get off our phones.
Right, exactly. So I think having that autonomy agent is really the sweet spot. It's that partner as you operate a vehicle or a drone or aircraft.
Let me ask you, we see in what I do, we see generative AI massively growing in popularity, both academically, professionally. We see a lot of creativity being either enabled or in some negative cases, maybe over relied on the autonomy component where folks are feeding in creative prompts to get the derived effect that they want. How do you see the role of AI, including generative AI tools that are out there? How do you see that evolving in the next few years in terms of?
I think AI is fantastic, and I think ChatGPT is fantastic. They're tools. I think we should look at them as tools. I mean, those type of systems can hallucinate or be given deliberately bad information, and you get garbage out. And so When you learn something that's not correct, you're going to learn it incorrectly, and that's what you're going to get as a result. So those are the cautions. But I think that theoretically, it's a wonderful thing to use, and as long as it's not mistrained, if you will, and doesn't perpetuate on that. But I think it's I see that as part of the future, big time.
Class, just to build on what Dr. Harbour is sharing here with the notion of hallucinations. This is why at the moment, when you drop a prompt into AI, ChatGPT, and you get an output, it is absolutely critical to read it, review it, and edit it. You can't just use it to write a paper because
That's right. That's right.
it'll spit out essentially spaghettification of a thesaurus. It makes it seem complicated and impressive, but it in the end means nothing if you're a subject matter expert. You read this and you can see through it. And so in some cases, students might be tempted. Let me just drop this in and create a paper around this, and then the professor gets it and goes, I know exactly what happened here, because it's filled with hallucinations or it's filled with just vague illusions. That this is where it's really good at establishing a framework. I like to say it's a great tool for breaking up the writer's block, or the getting past that initial maybe anxiety of getting started on a project. But in no way should we be entirely relying on it to fulfill the task. We need to double check it. We need to build that reliability and
Yes.
Trust in the system.
I absolutely agree. See a mistake, assuming one is a subject matter expert. When you see it give a mistake, correct it.
Yep.
Tell it that's wrong and correct it, and it will learn from that. Absolutely, Brent. You're so right. I mean, you can look at. I mean, I will play with it sometimes, and it will you're right. Writer's block kind of gets you going in the right direction, but you got to really careful, because most of what I read on there is like, nah, that's not quite right. That's not right at all. So you have to just sort of be cautious. It's kind of like it's an awesome Google. I mean, it's a smart Google kind of system, a search engine, but at the same time, it's kind of like an infant, and it falls and things of that nature as it walks. And that doesn't necessarily mean that it's going to become a full adult, brain surgeon either. You just have to use it carefully. I mean, I'm not against use, but you just have to be careful with it.
Yep. Agreed. So, what are some of the advances in AI that you're most excited about right now? Are there any specific technologies or tools that you think are particularly promising and that students should keep their eyes on?
Okay, you nailed it. So I really believe it is in the design the computer to be like the human brain. I really think that is the future, because we do such a wonderful job at what we do, and for a lot less power, we could beat the supercomputer in Japan and not have to use megawatts of power to do it from a decision computational perspective. And so if we design our future systems to be more like the human brain, we see increases in computational speed, reduction in power, and it's kind of a challenging science, because not a ton of research has been done in that arena. But what I do that all day long to push the envelope further. So I would recommend looking up neuromorphics. Neuromorphic engineering and Gen 3 algorithms and spiking neural networks. And there's others besides just a straight SNN. There's something called a sigma delta neural network, or you can do a combined CNN, which is very good at feature extraction, and then the SNN is better at temporal spatial information extraction, and you combine them together and you get an algorithm that will beat either one individually. So they both have their shortcomings, and you can get the best of both worlds, but that all is going to be in a neuromorphic realm. And so I think that I would take a keen look at that. I think we're going to see a huge growth in neuromorphic processors being used. So I tend to think more analog, for example, as opposed to digital. memory is co-located on the processor, like the human brain, for example. So you don't waste time going off processor or even near the processor. In the case of the GPU, you don't get a bottlenecks. It's just how we do it, and so that's what I see as the future. And again, the human autonomy teaming as the future as well. Not so much as just AI making all the decisions. It's AI aiding the human. And if you have a system, some of the parts may be pure AI because the human can't handle that workload. But ultimately, at the end of the day, the human's going to make the final decision.
I agree. And I think at a consumer level, we're going to start seeing this technology deployed at a much wider level. Alexa is going to be updated here through the Amazon network. We've got rollouts of the next gen of Siri. All these things that we use in our day-to-day with our phones or our home networks, we're going to start to have that capability. Microsoft Copilot, it's already happening in our writing tools. So this is all going to start to come together in our day to day, and it just makes sense that we're going to see it in the more technical side of things. As we get used to that HMI, that human machine interface, we're going to start to explore the space a lot more from the functional. And I'm excited to see what happens in things like auto navigation, and where it might actually be a more part of the automotive experience. Right now we have some kind of lower tech capability where self-driving, where it stays in the lane, or it follows the lane, or follows the car ahead of you, or we're getting to more and more capable features, and it's definitely crawl, walk, run, and we're nowhere near run yet. And it makes sense. I mean, there's a lot of liability with that, right?
Right.
We have the roadways with a lot of different risk and unforeseen variables. That's where, to me, when I look at AI and we talk about incorporating it into autonomous vehicles, it's getting so we have enough reliability in that system so we can trust its performance, so it's replicable in its results, and we understand its thinking process. I think that's probably one of the most difficult studies right now, is understanding how and why AI behave the way they do. Just because it's so new of a field, the study of machine learning. So,
Right. I agree. AI is explainable, understandable, and transparent is the direction that we're headed. And so, yeah, you're absolutely right.
so I've got one more question, then I'd like to open it up to the class. This is
Sure.
this is kind of a bit of a softball, but it's something I like to ask everybody who comes in, and that's, what tools or mechanisms do you personally use to stay up to date in this space? What are some of the strategies just for sifting through just the huge volume of material that's out there? How do you
Right.
how do you stay up to date?
So I do, Google Scholar, and I have specific words that are in the research that I do, and I check it daily as part of my job for the latest research that's going on. That's one of the things that I do. And then I try to do on my experimentation, where I'm allowed to publish on it to add to the community. Some of the stuff I do, I'm restricted from publishing due to Department of Defense requirements. But I like Google Scholar a lot. And then I belong to IEEE, and IEEE Explorer is another good source to check on daily. And then also AIAA is another organization, and various organizations that you all might belong to in UAS systems in the scholarly world. And then I attend conferences, either presenting or I attend them every year to stay, ahead of the power curve. So that's, so you get a sense. And then I have colleagues that I do research with in the area. And so we just together, am able to work in the space and know as things are progressing, worldwide. So I'm working, with Zurich Technical Institute in Germany and Switzerland, MIT, Berkeley as well. And then, yes, Embry-Riddle is another cutting edge university in the space, I know, and what Brent's doing and what you guys are studying. So I think, that's what I recommend. I don't really use like ChatGPT to do that kind of searching. I stick with, the traditional scholar pages and society pages. And then it's the people in my space, email them,
Yep.
pick up the phone and talk to them. LinkedIn, if you're not on LinkedIn, why aren't you on LinkedIn? Everyone I think who's doing this, anything at all, needs to be on LinkedIn. It's another real good source of information too, by the way. So that's what I do.
Outstanding. Well, and folks, now I'd like to open it up to you guys. If you don't mind, just put your hand up. I'll call on you. Hopefully, my speaker will route out and it'll be loud enough or not too loud for Dr. Harbour to hear your questions. If that does prove to be a problem, we'll just switch over to the chat and you'll type your question and I'll read it off there. So any questions? Okay, we got a couple. We'll start with Ryan Hudson.
Hi, I was wondering what your take on the potential for optical neural networks to be used for machine learning would be.
So optical drone networks, I make sure I understand the question. Optical drone networks for machine learning. That's correct.
Optical neural networks.
Optical neural networks.
I guess, yeah. So using vision type information, is that what he's asking?
Yes. Yeah, using for light processing.
So I think that's a very good thing. There's two kinds of vision sensors if we're going to stay within, visible light area. One is the traditional high resolution camera, high speed camera, or there's new technologies out there called the neuromorphic camera, again, based on neuromorphic technology that behaves more like the human eye. And it actually has a higher bandwidth and dynamic range than the high res camera, and it won't blur. So you can use it to even estimate closure and velocity. And then you can integrate the network that way. And I would probably go into, like SNR, SPy torch, SNR torch, which is a spiker neural network type network for using, it's a Python, it's very Python-like. But it's customized for SNNs to work with, like a camera system that certainly is neuromorphic. But yeah, I think that's, you can do it. I think that, or you can just use, again, the standard high res camera. You lose a little fidelity that way. You get more with an event camera, but you can do it that way as opposed to go to LiDAR and you can go to other modes, but you can certainly do it more traditionally optically, if that's answering your question a little bit.
Excellent.
Thank you very much.
Sure.
Heidi, did you still have a question? Go ahead, Heidi, and then Jim after.
Can you hear me now?
Yes, got you now.
Hi, Dr. Harbour. I'm curious, how has your background knowledge in neuroscience influenced your approach to developing AI systems, especially for uncrewed aerial systems, and specifically when it comes to understanding and replicating human cognitive functions?
So that's a very good question. So, I'm very fortunate that when I was in the uniformed service and then I became a civil servant, my education, I feel very blessed, was funded by the United States Air Force. And, undergrad, of course, was electrical engineering, robotics, and so I'm an engineer. And then the master's, aerospace engineering, Embry-Riddle, by the way. And then, but all engineering. And so when it came PhD time, they're like, hey, we want you to be more neuroscience based. And I'm like, hey, I'm an engineer. What the hey? But then I understood it because I talked about this was the early stage of neuromorphics. And so then I understood it. And so it was very apropos to do a PhD and very neuroscience based, either computationally, biologically, or even behaviorally. And so I did behavioral stuff as well. I did actually 1,000 hours of clinical internship as part of the program to learn all about the human. And so it really did help me when you go into neuromorphics and you're trying to imitate the human brain, to have a thorough background in cell biology, the neurons in the brain, and the spiking, and how they function, and the voltage, and how that all works and connects, and how it makes this, how we make decisions, how we learn, and then taking that both from a hardware software perspective and imitating it in silicon. And so I don't know if I could do it without a neuroscience background, quite frankly. And then I guess the other stuff just sort of rounds it out. So yeah, if anybody is wanting to go into if you don't have to have a degree, you don't have to have a PhD in neuroscience. I have plenty of folks that work for me that don't, and they're part of the whole team doing neuromorphic research. But it certainly is something to consider to go into if you want to do that.
Thank you, Dr. Harbour.
You're welcome.
Next up, we have Jim Howe.
Hey, good evening, Dr. Harbour. I'm sure you're getting this question a lot, but how do you see your research aligning or possibly diverging from the work that's being done with companies like Elon Musk's Neuralink, particularly in the terms of integrating the human brain interfaces with autonomous systems? Or maybe a better question would be, do you foresee the possibility of implantable hardware in the human brain that enhances our abilities through perhaps like an AI-driven architecture?
Yeah, so it's a very good question. So absolutely. I'm very much aligned on some of the research I do with what Elon Musk is doing. His folks at, when I say that, I mean, he's not likely doing it actually exactly himself, or he may be, I don't know, but anyway. But absolutely. So I think using neuromorphic technology, again, I respect, working with a partner at Zurich, Alicia, and she, we're looking at doing just that, either implanting the processor somewhere near the spine or in the brain or outside the human body, right? But communicating with the circuitry to that, of the human, the nervous system of the human, along with the brain, to basically, you can either do brain stimulation, there's different ways to help the human, so you can have a superhuman or someone who has deficits or disabilities. I mean, think of the possibilities. Someone that has an intellectual challenging situation, and you can take that away with a processor augmentation processor. I do. We just got to be careful. I mean, I'm not around trying to go, let's put chips in people's brains and go crazy with it. You just got to be careful. But yeah, I think neuromorphics is the way to go with that. You don't want that processor going hot. You might want to see it flexible. That it is not like rigid, things of that nature. So no, it's all very closely aligned with stuff that I do.
So just to note this, all you Halo fans, he's talking about creating Master Chief with Cortana here. So, all right, Paul.
Sure, I got high winds. I posted my my question there in the chat if it's okay.
Oh, okay, yeah, I'll read it out. So, how close to crossing the uncanny valley do you think AI is? I want to couch this question in terms of interfaces. You talked about garbage in, garbage out. People are able to use question context to develop answers. So I think focusing this question on AI's ability to look at context when interacting with people. And if you don't mind, I don't mind jumping in on this one a little bit, because this is just, I don't know if I've ever shared with you folks, one of my research focus areas topics as of late has been AI tools in the online digital classroom. And something we've started to see is this use of avatars. Now, you might think of it in terms of maybe deep fake videos where you can take, countless hours of celebrities or folks who have had their digital likenesses created. There's a lot of video footage, a lot of audio footage of their sound clips, and you can recreate them in a 3D rendered digital space through an avatar. This is now something that several companies are doing, that you can actually, like as an educator or somebody who wants to create, say, training videos, you can work with them to train a model that has your inherent, I guess, mannerisms. So if you speak a certain way, you tilt your head a certain way when you're talking, you use your hands like I do, it'll replicate that. And it's getting actually pretty good, because it's based off footage and modeling of you personally. So it's able to take that and kind of fill in gaps. And if you give it enough context, enough data, it can come up with a pretty good facsimile, especially when you're there to provide editorial or support of it in the long run. So the AI, and where you're coming with the uncanny valley, that's the ability of it to kind of pull off is this real without being creepy? Because our human brains are real good at telling when something's CGI, computer generated imagery. And when it's bad, it's bad. And, you just look back at movies, you see that scale has slid so far. It's a little different, I think, in the generative space, because what it's doing is creating a facsimile. It's not actually, as Dr. Harbour kind of mentioned earlier, it's not self-aware. It's not thinking. It's mimicking human language. It's generating human language through routines and through parsing out the input. So the uncanny valley piece, I'll ask you on your thoughts on this, Stephen. But yeah, my belief is we're getting really close with intentional tools, but we're not trying to necessarily replicate human. We're not trying to artificially imply that this thing is human.
Yeah, I agree with you. I agree with everything you said. Yeah. So, I mean, the more variables that we can, in the data, we'll call it a data set of the varying attributes, the more attributes we can get, the more little idiosyncrasies we can get of something that's pretending to be human-like, if you will, or human, the more information we can get. So it's more of a supervised learning space of, well, wait a minute, this is really the actual human. And if you have enough attributes and you can get enough granularity and fidelity that the system will pick it up on its own and go, yeah, no, that's AI. That's AI. It's not a human. So that's part of the the discussion part. I think that's but if we don't get enough variables and we don't have a good enough training data set that's more real-like, then yeah, all sorts of things can be fooled at that point in time. But you'd have to get as much of the data as you can get if you want to safeguard that, using AI to safeguard it for you.
Yeah, and that's AI tools are being used to detect whether things have been created with AI. So it's kind of interesting and ironic how that comes full circle.
It is, isn't it? Yes.
Well, folks, does anybody else have first time hearing about the uncanny valley effect? Now that's an interesting rabbit hole to go down. I strongly encourage you to take a look at that and see what it is. You'll see it from early robotics, where animatronics and things of that nature are very creepy. They're very disturbing the closer they get to human mimicry without being seamless. It's just it's an unnerving thing, and you can see there's been a lot of study regarding it. So I encourage you to take a look at that, since we are in the field of mobile robotics. Anybody else have any questions? Oh, okay, we've got Matthew and Monty.
Yeah, hi. Can you hear me all right, Dr. T?
Yep, loud and clear.
Yeah, good evening, Dr. Harbour. As you were giving your lecture, I was trying to better understand the premise of the neuromorphic computing. I came across an article online regarding the Air Force's development of the Blue Raven supercomputer. From what I gathered, at least from like an application standpoint, the technology seemed to be explained as it allows UAS or drone operators to be provided with information that is, as they quote, more analytical and less just raw data. My question is, could you provide an example with what that would look like from an application standpoint, or like how would I, as an operator, see this technology enhance my already existing capabilities?
So that would be very much like, so for example, I mean, if you look at satellite imagery, or any other kind of ISR data being collected, it's typically in the raw. It's just pixels and bits and ones and zeros, and it's not processed in the satellite. It's not processed on the UAS. It's typed down, and then and then there's some delay action, and then that may be presented a little bit still the same to the user. If I'm, and so now the user has to do computations, and it slows things down. Maybe there's a little bit of analytics that's happening, as you modernize for the user, but this would enables that, it kind of almost gives an answer, if you will, very obviously, to the human operator. That's the direction we're trying to head down to, so we reduce the time and better judgments can be made, of what's going on, and with less errors. Humans are very good, but humans can get tired also, for example. So, just being, just straight, very accurate, probably, and very technical information, that kind of hard to either pre-process or digest. The more processing you can do, going out near the, near the edge, if you can actually do processing, and then looking at that neuromorphically on the say, a drone that's collecting ISR data, for example, the more you can do there, and so as it heads down to where it needs to be looked at by the operator, for example, it's more usable, it's faster, it's better, and so looking at different ways to do that, using in the machine learning space and the AI space. But again, if you can go neuromorphic, you get more effective for a lot less power, a lot less heat, and it's faster. And getting that more towards the edge, as it feeds a supercomputer system, and then, using something, like, I'm just going to throw it out there, a system that is, founded in, more human brain-like decision making. I think the better it is. So I hope that sort of answered your question, or got close to it.
Yeah, absolutely, sir. Thank you very much.
Excellent. Well, any remaining questions before we wrap up? Monty, did you have? Okay, go ahead.
Yeah, I just wanted to ask about nanotechnology, AI, and UAS, and how far we are from interoperability between systems using AI to talk to each other to accomplish tasks.
Gotcha. So yeah, nano, we go from micro circuits, right, to nano circuits. smaller. I think that, once again, getting more towards, analog based and neuromorphics, that's more doable. And you're right, you can have a very small system and you have your nano architecture. Let's say it's analog based, let's say it's neuromorphic based, but then it's going to have to interface with a system that is more clunky, like a standard GPU kind of thing. And so the interfaces can make or break you. And so the interfacing is very important, both from a hardware perspective, and we tend to like to use C++ and the interface making between systems to make up a shortfall. Either you can speed something up or you slow something down to match something that's faster. You typically are limited. Your latency is going to, for the whole system, is going to be what your absolute longest latency is. And that's what you're kind of stuck with. So, but yes, we are going nano in a lot of different areas, especially with very tiny. So it's almost going nano in general. But yeah, you got to make it very operable and you got to stick with it or it becomes useless. That's unless you got other questions, Brent, that's kind of all I got on that one.
I think we're wrapped up. And on that note, I just want to thank everybody for joining us tonight, as well as a major thank you to you, Steve, for sharing your thoughts and expertise.
My pleasure. I love doing this kind of stuff.
Well, and this is one of those sessions that, I know it came in a little bit of a challenge, but to me, I think we got a heck of a lot more out of it because we actually got to sit down for a real conversation, a real discussion, talk through this topic. To me, this results in a lot more kind of dissemination of important information here. So conversations are always a plus on my part. I'm going to stop the recording and then just kind of stick around for a couple minutes.